that the astronauts read out.
Gravitational effect of those planets.
Hi, I'm Lee, and this is NASA Now.
3, 2, 1.
Shooting for safety in NASA's Ballistics Lab, where gas guns are used to study the dynamics of high-speed projectiles and their impact on targets. That's ahead. First, here's what's happening at NASA Now. NASA's Hubble Space Telescope, which recently logged its 1 millionth science observation, has discovered a fourth moon orbiting the icy dwarf planet Pluto. The tiny new satellite, temporarily named P4, is the smallest moon discovered around Pluto. It has an estimated diameter of 8 to 21 miles, or 13 to 34 kilometers. By comparison, Pluto's largest moon is 648 miles, or 1,043 kilometers across. It is remarkable that Hubble's cameras enable us to see such a tiny object so clearly from a distance of more than 5 billion kilometers. Now, let's take a look at the past.
As a direct response to the Columbia STS-107 tragedy, which occurred February 1st in 2003, the Ballistics Impact team at the NASA Glenn Research Center started testing shuttle components to gain greater insight into that accident. Today, the Ballistics Lab continues to test components and materials to ensure safe space and air travel.
At the NASA Glenn Research Center in Cleveland, Ohio, the Ballistics Impact team works hard, discovering and understanding ways to make aeronautics and space flights safer. With us today is aerospace engineer Matt Melis, who's going to take Newton's Laws of Motion and turn them into real-life situations.
Hi, Lee.
Hi, Matt.
Welcome to the Ballistics Lab.
Thanks. What are we looking at here?
This is the biggest of 3 guns that we have in the Ballistics Lab. We have a kind of a small, medium, and large, and this is the big daddy of them all. We typically use this to fire jet engine fan blades at targets in the target area to make sure that our jet engines are safe and can withstand a blade impact should that happen during flight or takeoff. These are 2 little objects we call blade simulating projectiles. And we use these dots to track in our high-speed cameras the motion, the rotation, and the translation to get velocities and motion as it travels through the target area.
When doing a test, what do you consider?
Oftentimes, one of the things that's misunderstood in impact dynamics is kinetic energy. Kinetic energy is energy in motion, and that energy has to be dissipated when it impacts something, and it usually gives it up in heat or destruction energy. So it's not really how much something weighs, it's how fast something is going.
How do Newton's laws of motion come into play at the Ballistics Lab?
Well, Newton's laws of motion basically govern everything that happens in our physical world. It says how things move as a response to force, how mass and forces interact with one another. But they basically guide how everything happens when we release the energy at the end of that gun down there and the projectile passes down the barrel and hits the target.
3, 2, 1.
How was the Ballistics Lab able to assist with the space shuttles returning to space?
We were also brought in after the Columbia accident investigation, just a few days after the event took place, to help assist with finding out how the accident occurred. Effectively, what happened was a piece of foam about a pound or a pound and a half came off of the external tank, hit the leading edge of the vehicle, which had a reinforced carbon-carbon thermal protection system on it. That reinforced carbon-carbon was compromised as a result of that impact. It had a crack or a hole in it, and it enabled hot gas to get in and break the orbiter up on re-entry into Earth's atmosphere.
Matt, we've moved over to another room in the Ballistics Lab. Tell us what gun this is.
This is the medium gun. You can see it has a dramatically smaller barrel, probably in the order of about 3 inches on the inside. We have, again, like with the big gun, we have many barrels that we can swap out just to meet the exact diameter of what we want to shoot.
And what types of projectiles do we have here?
These are projectiles that actually came from the shuttle program. This is an ablator material, and that means it ablates, it burns away. It's a thermal protection material, but this is some material that we were worried about potentially coming off during a launch of a space shuttle, and so we tested this on reinforced carbon-carbon. And then this is actually the foam. You can see how light that is. That just weighs what a sheet of paper weighs. It's almost 100% air. And all of us were caught at some level by surprise when something as light as a feather could actually critically damage a space shuttle orbiter.
What an exciting career you have.
Yeah, it
why did
is.
you decide to pursue aerospace engineering?
Well, I think almost everybody, if you talk at NASA, everybody you talk to has really, since they were young, quite young, wanted to work for NASA. They wanted to be in rockets, either be associated with rockets or fly in rockets, and I was no exception. The moon landings were part of my generation. I was 10 years old when Neil Armstrong and Buzz Aldrin landed on the moon, and that sort of motivated me and inspired me to go on.
Did you know that the gas guns in the Ballistics Impact Lab can shoot speeds of up to 609 meters per second? That's more than 3,218 kilometers per hour, or 1,998 miles per hour.
Now it's time to check out what's up.
As we celebrate 30 years of NASA's space shuttle program, look up and think of this. The minimum speed that we talk about getting into orbit is Mach 25. That's 25 times the speed of sound, and it's roughly 17,500 miles per hour, or 28,157 kilometers an hour. When the astronauts re-enter the Earth's atmosphere, they are traveling at about 17,000 miles an hour, or 28,000 kilometers an hour. And within 40 minutes of entering the atmosphere, entry interface they call it, they are down on the landing strip, having burned off all that kinetic energy.
Hey teachers, here's an opportunity for your students to put their math skills to work in a real-world scenario.
Your class will calculate the trajectory, acceleration, and thrust necessary in order for a spacecraft to enter orbit around the Earth. Just visit the NASA Explorer School's virtual campus and check out the lesson entitled Exploring Space Through Math, Space Shuttle Ascent.
Well, that's it for NASA Now. Be sure to tune in next week when we explain the how and why behind volcanoes, earthquakes, and mountains. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.